Okay, so now today we're going to be talking about the unit circle. The unit circle is one of the biggest points of what we're working with, what we want to achieve in this chapter, in this section. So let's get right to it. So today we're really going to look at finding the 6 trig functions using the unit circle. It'll be more in the next lesson that we look at finding the values in standard position when you're given a point. So today we're really going to just kind of get an overview of what that unit circle is. So let's remind ourselves what our 30, 60, 90 triangle looks like and what our 45, 45, 90 and what our 60, 30, 90 triangle looks like. So when we have a 6-degree angle, and there's a couple different ways you can see the 30, 60, 90, that's why I have the two showing two different ways here. And I just wanted to kind of remind ourselves that we're looking at the short side, the long side here, and the hypotenuse when we're looking at a 30, 60, 90 triangle. With the 45, 40, that the two sides here are the same and that the hypotenuse is the leg side times square root of 2. All right, so let's look at this unit circle, or this circle, or we're going to start with the unit circle. So we're looking at the 30, 60, 90 triangle, a 30-degree triangle. Now, what if we took our 30-degree triangle here, and we said, let's put it on the coordinate axes, all right? So what does 30 degrees on a coordinate axes look like? So here's our 30 degrees. All right, that's exactly what it looks like right there. But then we also, in the previous lesson, learned about reference angles. And we learned how a reference angle can still be a 30-degree angle. So in the first quadrant, that's what our 30-degree reference angle looks like. In the second quadrant, that's what our 30-degree reference angle looks like. So this still has a 30-degree reference angle. This still has a 30-degree reference angle. It's the same triangle, just has been flipped over the y-axis. Let's do the same thing with the third quadrant. Here's our third quadrant. Again, we have 30 degrees here, 30 degrees here, 30 degrees here. We have the same triangles. It's just kind of being rotated or flipped around here. Same thing if we have it in our fourth quadrant. So these are all 30-degree angles, 30-degree triangles. All of the rules and values that are in a 30-degree triangle holds. So now let's think, okay, so that's what it looks like when we have the 30 degrees. Let's apply that same thing to a 45 degree. Well, there's a 30 degree and I put the 45 degree there. All right, so the green is the 45, so this is my 45. The red was my 30-degree angle. Well, we can do that same thing of saying, hey, what's it like when that 45-degree angle is in the second quadrant or the third quadrant or the fourth quadrant? And there's those angles. Now the next thing we're going to look at is, hey, what about if it's a 60 degree? So there's the 30 and the 45 together. Now let's say what happens if we have a 60 degree. The blue, if you remember, these are our 60-degree angles. The green was 45 degrees, and the red was 30 degrees. And that's kind of how it goes when we go around the circle. It goes 30, 45, 60. We come up here and it goes to 90 and it comes around. And then the reference angles kind of go back to that 60 here, 45 here, and 30 here, all right, for this angle. Okay, so we kind of can see how it works around. And the idea that somebody came up with at some point is, boy, it would be great if they all fit in the same circle. But then what they found is they don't all fit in the same circle if we try to keep the x's the same. And then they thought, well, let's think about this. How can we possibly keep them all the same? What if instead we made all the hypotenuses the same? All right, so in other words, we made a circle and the radius was always 1. A circle of radius of 1. Okay, that would mean here that this was 1 unit. That would mean that if this were the 45-degree triangle, for it to come all the way to the end, it would also have to be 1 unit. It meant for the red line, for this red line to come all the way to the end, it'd have to be 1 unit. So then let's talk about that. What would it look like if the hypotenuse was 1 unit for all of these? Okay, let's just talk about the 30, 60, 90. What we know is that the short side, when I multiply it by 2, always gives me the longer side. So here's my short side. To multiply it by 2, I get 1. So this short side must have been 1/2 to begin with. Then the long side is always the short side times the square root of 3. So what is 1/2 times the square root of 3? Well, we could just write that as square root of 3 over 2. And that's exactly what we get in the unit circle. If we're going to move here to the 60, the same rules apply. We'd still have 1/2 here, and this would be square root of 3 over 2. In the 45, 45, 90, that was a little bit tougher because whatever we had here was the same. And then when I took it times the square root of 2, I got my hypotenuse. Now we want our hypotenuse to be 1. Well, if I divided both sides by square root of 2, I would get here that x equals 1 over square root of 2. Now, if we're going to keep using this over and over again, we really should rationalize the denominator. We should multiply by square root of 2 over square root of 2. The benefit of this is the denominator no longer has a radical in it. And if we're going to use it over and over again, we should make sure it doesn't have a radical. So our x here, it's square root of 2 over 2. So we have square root of 2 over 2 here on both our legs, okay? So let's see what that looks like here when we look at it in the unit circle. So when we look here at our first one, and I know this one's hard to see and I'm sorry about that. So if we look at our 30 degrees right here, and if we think about, okay, what happens in this, in the two legs of our 30 degrees? This was our one. This leg was 1/2, if you remember, and this one was right here, square root of 3 over 2. So what you're seeing here in parentheses is square root of 3 over 2, and then comma 1/2. And that's kind of exactly what this point right here is saying. That's what's at that point. It's the point, you go to the right square root of 3 over 2 and up 1/2. And so that's the point that we have. Let's use that logic and do it for the 45. This point right here is at square root, and I know it's hard to see, square root of 2 over 2 here. And this one's square root of 2 over 2. So that's what this point is. I'm going square root of 2 over 2 over and square root of 2 over 2 up. I can use that same logic for the 60 degree. Now I'm going 1/2 to the right and up square root of 3 over 2. We'll talk about the 90 degree in a minute. But it works as we're going around into the different quadrants. Here, I'd be going a negative 1/2 because I'm going from 0, 0, and I'm going this direction, this little amount, which is a negative 1/2, all right? And then I go up a positive square root of 3 over 2. So it's negative 1/2 positive square root of 3 over 2. I'm going to keep going here. Notice how it's negative square root of 2 over 2, positive square root of 2. So I go negative square root of 2 over 2, and then positive square root of 2 over 2. Here, I'm going to do the same thing. It's negative square root of 3 over 2 and positive 1/2. We'll get to the 180 here in a minute. Let's go down to the third angle, or the 30 degree reference angle in the third quadrant, excuse me. Now we're going negative and negative. So I go negative square root of 3 over 2 and a negative 1/2. All right, let's look here at the 45. It's negative square root of 2 over 2, negative square root of 2 over 2. Here we go to the negative. This is, again, a 60 degree reference angle. We're actually at 240 degrees. And that one is a negative 1/2, negative square root of 3 over 2. Don't worry that you have to have this memorized just yet. Hopefully it'll become more human nature to you, more kind of understandable as we go through. Now we're at positive 1/2 and negative square root of 3 over 2 in the fourth quadrant here. So we're at that 60 degree reference angle in the fourth quadrant. Let's look at in the 45 degree reference angle. We're at positive square root of 2 over 2 and then negative square root of 2 over 2. Let's look at what it looks like for the 30 degree. It's negative square root of 3 over 2 and positive square root of, or excuse me, positive and negative. So this is our positive, this is our negative. All right. You'll be getting a handout that looks a lot like this, and yours will be easier to see than what you can see here on the board. But then let's talk about what we have here. What happens when you are here on the edges? These are called quadrangles. When we're at 0 degrees, 90 degrees, 180 degrees, and then 270 degrees. What happens when you're exactly there on an exact measure? Well, at 90 degrees, this is considered the point here, 0, 1, and I know it's hard to see that. It's the point 0, 1. So over here is the point 1, 0, and we're going to talk about what that means here in a minute. This is the point 0, 1, and this is the point 1, 0. Now before, when I showed you, when we were at 30 degrees, and if you notice here, I'm going to go back. Right here, say let's here we're at this 30 degrees. If I said I want to know the sine of this, well, the sine is the opposite over the hypotenuse. So I have here, I'm going to highlight it here a little bit more, opposite over hypotenuse. Okay, so opposite over hypotenuse, this would be -1/2, this would be 1, so it's really just -1/2. Notice how that's y. Okay, that's not a coincidence. It always will be y. Y always will be the sine, okay? Now if I said, okay, I want to find the cosine. Well, the cosine here would be square root of 3 over 2 over the 1. Well, it would just be square root of 3 over 2. Notice how that's your x. X will always be your cosine. So it's kind of given like this, cosine comma sine. All right, and it's kind of like x and y. All right, well, the same thing holds here when we have our quadrangles. So like this point right here at 90 degrees, the sine would be 1. So the sine of 90 degrees is a 1, and the cosine of 90 degrees is 0. Here at 180, the sine of 180 degrees is 0, and the cosine of 180 degrees is 1. See how it just follows? Oh, and I think I made a mistake. This would actually be a -1, so it's a -1 there. And this is a -1. So here, down here at 270, sine of 270 degrees is 1. Cosine of 270 degrees, sorry, it was -1, is 0. So it was 0, -1. X, Y, cosine, sine. Here at 0 degrees, right here, we have that the sine of 0 degrees, also 360 degrees, is 0. The cosine of 0 degrees, also 360 degrees, is 1. All right, so we had cosine, sine here. Now let me see if I can show you in a little bit better way. Well, this is another example. This is actually using polar values as well, and I'm going to be giving you this, but I liked what it said here. It's just reminding us we have cosine sine. This is really our cosine sine for 30 degrees. This is our cosine sine for 45 degrees, our cosine sine for 60 degrees, our cosine sine for 90 degrees, and so on. All right, let's look what else we have. So this is something that you really should be writing down here. That sine is really our y divided by our radius. Now we have our unit circle. So in the unit circle that the radius is 1, the sine is y, okay? And that's really important. The cosine is x. So that makes the cosecant 1 over y, the secant 1 over x. And then it follows that the tangent is actually y over x and the cotangent is x over y. Please write this down. All right, I want you to take some time, pause the video, and copy this down. I need all of this in your notes. And once you use it more, it'll be more understandable. I understand that right now you might be saying, it's a little confusing. It will get more understandable, okay? And we'll stop now and we'll go to the next video to get some examples. So I'm going to have you stop here after you just copy this down, and we'll go to the next video for some examples.